Okay, pause and copy. Pause and copy. Okay. So we have a partitioned matrix or a block matrix or whatever. Um, we're going to need to find the inverse of this funny thing. So we'll do that in a very kind of basic manner. We'll say let A inverse be a matrix filled with matrix variables, and then try to solve for x, y, z, and w. So A times A inverse is going to be B, C, D, 0 times x, y, z, w. And what does that equal? Well, it must equal the identity matrix, right? Which is going to be of this form. I haven't talked about the size of the blocks. If you want, you can assume that B is n by n, and let's say D is m by m. So C is, well, why don't you figure that one out? Okay, where was I? I'm looking at this equation here, and I'm going to try to solve for x, y, z, and w in terms of B, C, and D. So I'll start by doing this product here, and then I will see what I get. Okay, so what do I get? I get bx plus cz by plus cw dz dw still equal to the identity matrix here. So what do we extract from this? Well, we extract that this entry must be the same as this one. And so on and so forth. By plus cw is equal to the zero matrix. Dz is equal to zero matrix. Dw is equal to identity. So I get four equations, and we have four variables, x, y, z, w. Okay, B, C, and D are, I guess you'd say, constants, constant matrices. And we want to find x, y, z, and w in terms of B, C, and D. So what do I get? Here, you can stick a D inverse here and stick a D inverse here and get that Z is zero matrix. Likewise, you can get W is D inverse. So here I have found Z and W. Now I just need to find X and Y. And I'll work with these first two equations. So what do I get? Bx plus c, and what is z? C is 0. C, well, that's just 0, right? Because this is 0 is equal to I. So bx is I. So x is b inverse. And I'll take this equation down here. So by plus c, what's w? W is d inverse. So d inverse is 0. So by is equal to minus cd inverse. So y is equal to minus c d inverse b inverse on the right. Oh no. Oh no, mistake. That's no good. I put my b inverse in the wrong place. It must go on the left. Because you are doing the same operation to both sides, right? You're putting a b inverse here on the left of the expression. So you put a b inverse, right here. All right, I think I'm done. I have my matrix A inverse, which was x, which is b inverse, which I found up here. And then I had y minus b inverse c d inverse, and then x, y, z. Z was 0, I believe. And w, what was w? D inverse, if I'm not mistaken. Don't believe I am. Let's just scan up and check. Have a peek. There we go. All right, there you have it. Inverted my, excuse me, my matrix. Okay, try one of these. Try something similar, I suppose. A is equal to okay, similar idea. I want you to find A inverse. Similar assumptions. Okay, B, C, D. These are all square matrices and invertible. So, pause, give it a try. Pause, copy, give it a try. Okay, what do I do? B0, C, D. I do the same thing. I go X, Y, Z. W is equal to identity of, oops, inappropriate type. And then I would get, what do I get? Bx, By. Shoot. Shucks. So expanding the left-hand side equal to the right hand side. So immediately I see that x is B inverse. Okay, just by looking at this and this. And then by looking at this and this, I see that y must be 0. 0 matrix, right? Not 0 the number. Careful with your conception of that 0 there. Conception. I don't know. Cx plus tz, cx plus dz, dz. Oh, I already said that x was B inverse, so why don't I put that there? Is equal to 0. So what am I solving for? Z is equal to negative D inverse C B inverse. And then finally, C 0 plus dW is equal to the identity. So W is D inverse. So what's A inverse? It is X, Y, Z, W. Okay, I did that kind of quickly, so why don't I double check what I did? So, start up here. Did I multiply properly? Yeah, it looks good. Cx plus dz, cy plus dw, yes. Yeah, 0, c. Ba ba dee boop boop ba ba ba. All right, looks good to me. Looks good to me.